Assalamualaikum and hello everyone. My name is Khairana Aula binti Ahmad Kashfullah, and today I would like to talk to you about something we often overlook but rely on every day, which is springs. Spring is a mechanical component made of elastic material, usually metals like steel, for storing mechanical energy and release it when needed. It does so by deforming under load, compression, extension or twisting, and then returning to its original shape when the load is removed. Now let's take a closer look at the various types of springs, how they function, and where we typically see them used. Let's begin with compression springs. These are probably the most common type. As the name suggests, they resist compressive force. When a load is applied, they shorten and absorb energy. You will find them in everyday items like car suspension and pants, where their ability to compress and rebound is crucial. Now, move to the next part, we have tension springs, also known as extension springs. Unlike compression springs, these stretch under load and pull back to their original length. When the force is removed, you might have seen them in trampolines or garage door, where they help manage tension and provide balance. So there is another interesting type of spring, which is the torsion spring. This works by twisting under torque and store rotational energy. Think of clothespins and vehicle hinge. Both rely on torsion springs to function properly. So now we're moving on to the lead spring. These are made from layered metal strips and are designed to flex under load. They are key component in truck suspension system, offering support and shock absorption on rough roads. Then there is a disc spring, also known as Belleville washer. These are cone-shaped washers that are compact, strong, and capable of withstanding high loads. They are commonly used in clutch and valve, where space is limited but performance is critical. And lastly, we have spiral springs. These are spiral-shaped and offer compact and progressive resistance. You will find them in heavy machinery and shock absorbers, where consistent force and durability are essentials.
Assalamualaikum and hi everyone. My name is Nur Fatin Kisina binti Muhammad Yusri, and today I will be presenting about springs. I will explain about metal springs. There are a few common materials used. First, we have music wire. It's really strong and can handle a lot of stretching, so it's fatigue resistant. Then, stainless steel. This one is corrosion resistant, so it is perfect for things like marine or medical use. Next, phosphor, bronze, and beryllium copper. Both have good electrical conductivity, which means they are often used in electrical parts. And lastly, chrome silicon and chrome vanadium. These are used for high stress or high temperature environments like in engines or machinery. Now, moving on to non-metal springs. The first one is plastic. It is lightweight and also resistant to corrosion, so it doesn't rust easily. Next is rubber. This one is used in vibration dampers or seals to reduce noise and absorb shock. And the last one, fluid or gas springs. These use compresses gas or oil for damping. You can usually find them in car boots or even in office chairs. So overall, non-metal springs are great for flexible and anti-rust applications.
Hi guys, my name is Adam Mukris, and today I would like to present to you about characteristics of spring. The first one is elasticity. Elasticity is the ability of spring to return its original shape. The second one is spring constant. The symbol is K. The K. Stiffness, force per unit of displacement. The third one is fatigue resistance. Spring can withstand repeated loading. The fourth one is corrosion resistance, important for harsh environment. It's like rain and sun. The last one is load capacity, maximum force before permanent deformation. The meaning is like every spring has their own maximum force before it's not able to return back its original shape. Do you know Based on Hooke's law, the extension of an elastic object is directly proportional to force applied. The formula is F equal to Kx. Another fun fact: when you pull a spring, it stretches. The more you pull, the more it stretches. But if you pull too much, the spring goes past of the elastic limits and it will not come back to its original shape.
Springs have a wide range of applications across various industries in the automotive sector. Springs are essential in suspension systems, clutch mechanism, and engine valve operations. Within industrial machinery, they function as vibration dampers and are used in actuators to ensure precise motion control. Consumer products such as pens, toys, hinges, and mattresses also rely on springs for flexibility and movement. In medical technology, springs are applied in surgical tools and prosthetic devices to provide control, motion, and force. In the field of electronics, springs are used in battery contacts and switch mechanism to maintain consistent electrical performance. Lastly, in aerospace, springs are crucial components in landing gear system and flight control surfaces, contributing to stability, safety, and reliability. Overall, springs serve as vital components that convert mechanical energy and maintain functionality across many applications.
Okay guys, let's move on to the next part. The next part is the inspection of springs. There are three methods or three ways for you to inspect the springs. The first one is visual inspections. The visual inspections is used to check for cracks, corrosion, or surface defects. Visual inspection is also used to verify dimensions and surface finish. The second one is a dimensional inspection. Use calipers, micrometers, height gauge. Confirm compress length and coil spacing. The last one is spring rate verification. Measure force versus displacement. Compare with design spring constant, K.
So what is spring testing? Spring testing is a critical process of ensures the performance, reliability, and safety of spring components used across industries. Let's take a closer look at the different testing methods used to evaluate spring quality. First is load testing. Load testing involves applying known loads to the spring and measuring its deflection. This process helps determine the spring stiffness, load capacity, and overall compliance with design specifications. The second one is fatigue testing. In fatigue testing, springs are subjected to repeat load cycles to simulate real-world conditions. This assessment helps identify the fatigue lift and endurance limit of the spring, ensuring it performs reliably throughout its service life. The third one is tensile testing. Tensile testing is performed on the wire material before coiling. By measuring tensile strength, yield strength, and elongation, we verify that materials meet all mechanical requirements for spring manufacturing. For torsion springs, they have a special spring testing which is called torque testing. Torque testing is used to measure angular displacement under load. This ensures the torque characteristic align precisely with design parameters and functional expectations. Next is hardness testing. Using the Rockwell method, determines the hardness of the materials. This provides an indication of its strength, durability, and resistance to wear or deformation under stress. Finally, we perform non-destructive testing, or in a short form, we call it as NDT, to detect defects without damaging the spring. There are three main techniques, which is first one, magnetic particle testing. It is used for ferromagnetic materials, and this method identifies surface and near surface crack. The second one, dye penetrant testing, which is applied to non-ferrous metals and it reveals surface flaws and discontinuities. The third one is ultrasonic testing, utilized for larger or more complex springs, and this method detects internal defects and inconsistency. By combining these rigorous testing methods, engineers can confirm that every spring meets the highest standards of quality, precision, and safety. Spring testing is not just about measurement, it's about ensuring dependable performance in every application. That's all for me. Thank you.